high blood pressure who are eating spam, people without high blood pressure who are not eating spam, follow them over time, and record whether high blood pressure is develops more commonly among the spam users than among the non-spam users. So back in your study design, you want certain inclusion-exclusion criteria set forth. And the main ones, the exclusion criteria, is that you don't already have the outcome if you want to be measuring incidence of disease. So there are two ways we measure incidence of disease. One is called cumulative incidence. You just look at the proportion of people who develop a disease over a period of time. We calculate it by taking the number of people who develop the disease by the number of people which we are following. But to do this calculation, you have to have a certain condition. You have to have complete follow-up on each person, meaning you have to be able to say that each person either developed the disease or they didn't develop the disease, and everyone was followed for the same amount of time. And the problems we worry about are things called competing risks and losses to follow-up. If I just move ahead to the next slide, this is the type of data you're going to have if you want to measure, say, the cumulative incidence for developing coronary heart disease. Each line represents a different person. The lengths of the line on the bottom correspond to the length of the study. Everyone's going to be followed for 20 years. And everyone is either going to develop coronary heart disease or they don't develop coronary heart disease. This is the ideal data we would have to have, because we can say without a doubt which people developed coronary heart disease and which people did not develop coronary heart disease during the 20 years of follow-up. Unfortunately, what happens, we have data that looks more like this. We plan to follow everybody for 20 years. Plan to see who develops coronary heart disease and who doesn't. But some of the people don't last for 20 years. They might develop another cause, another condition that leads them to dying. Once you're dead, you can no longer develop coronary heart disease. So if you developed a cancer 10 years into the study, and then you died from that cancer 2 years later, 12 years into the study, you can't tell me whether you would have developed or would not have developed coronary heart disease at year 15 had you not died from cancer. Also, we have people who we lose contact with. They don't come back to their follow-up exams. We don't know whether they did or did not develop coronary heart disease. The last time we saw them was 14 years into the study, and we lost contact with them. We don't know whether they did or did not develop coronary heart disease. When you have these deaths due to other causes, or when you have losses to follow-up, going back to the slide 2 slides ago, we cannot calculate this cumulative incidence because we don't know for sure whether these people who are lost to follow-up or these people who die from a different disease would have developed the disease in question, coronary heart disease, or would not have developed coronary heart disease if they had had full 20 years of follow-up. But what can you do? Calculate incidence rates. You calculate the number of disease cases that occur, not divided by the number of people, but divided by the amount of person time. So the people who didn't develop coronary heart disease and were followed for 20 years, they give you 20 years of follow-up. The person who died from cancer 12 years into the study gives you 12 years of follow-up. The person who was lost to follow-up 14 years into the study gives you 14 years of follow-up. You add all that person time together, so everyone is contributing to your study as long as they remained at risk for developing the disease. Those people who died from a different cause of death, or those people who are lost to follow-up, were no longer at risk for developing your disease once they died from another cause or once they were lost to follow-up. So you accrue person time as you follow people through the study. So to give you an example, another study I'm going to ask you to read for next week, if I can just move ahead for a second. Oops, I think I skipped over it. If I can go back. Slides. This is from a large experimental study that Marjorie, I believe, was a part of. And what we have here is the incidence of people developing diabetes, broken down by age groups, by sex groups, by racial ethnic groups. What we have here in the first column are the number of people in each of these different groups. What we have next to them are what we call incidence. And notice incidence is reported as cases per 100 person years. Because in this study, that I'm asking for people. Notice that there are 3,000 people in this study. And to enroll that many people into the study, people who were at high risk for developing diabetes, it took a long period of time. It took them between 1996 and 1999 to enroll people into the study. Some people were followed, those who enrolled in 1996, for longer periods of time than those people who enrolled in 1999. So not everyone was followed for the same amount of time. The average length of follow-up was almost 3 years to 2.8 years, but it ranged from as low as 1.8 years to as high as 4.6 years. So the only way you can measure incidence in this particular study is not by measuring proportions or cumulative incidence, but by measuring these incidence rates. Number of cases of people who develop diabetes by amount of person time that these people in each of these different groups contributed to your study. So realize that the design of the study, in terms of the amount of person time that people are contributing, determines whether you're going to be measuring incidence rates or cumulative incidence. And to measure cumulative incidence, you're going to have to require everyone being followed for a fixed period of time. That's not true here. When you have incidence rate data, you can still estimate cumulative incidence if you use life table information, survival analysis. This is an example of cumulative incidence in that same paper being calculated indirectly from those incidence rates by doing a life table analysis. What we have here are cumulative incidence at different periods of time. So the right of the step is the cumulative incidence of diabetes at different periods of follow-up for the three groups of people who were compared in that group. But these were not measured as direct proportions. These were measured using survival analysis, something we might be able to talk about when we get to the statistics part of this class. Well, in summary, what we've done so far is I've talked about different ways we can measure different types of outcomes. Nominal outcomes, ordinal outcomes, continuous outcomes, spending a fair amount of time on binary outcomes, talking about incidence and prevalence. The last thing I want to talk today, which is probably the more important piece, how do we link those outcomes to risk between risk factors and outcomes? And fortunately, that's the easy part. Because what I'd like you to do is think a minute. If I gave you two numbers, think of any two numbers you want in your mind. And I said you could take your calculator out of your pocket or out of your desk and do anything you want to those two numbers. You can add them together, you can subtract one from the other, you can multiply them together, you can divide one by the other. You could use all those other keys on your calculator that I don't know how to use. You could raise one number to the power which is equal to the other number. You could take sines, cosines, anything you wanted, square roots. But at the end of the day, what I want you to do is from those two numbers is count whether the first number I gave you was bigger than the second number I gave you, less than the second number I gave you, or equal to the second number I gave you. And the point is that all these measures of association, which are calculated by comparing the outcome in one group of people, the exposed group, the spam users, the outcome in another group of people, the non-exposed users, and the non-spam users, all these measures of association are done by doing one of two things. The only calculation you can do to two numbers to come up with one number, one value from those two numbers, to be able to tell me whether the first number was bigger than, equal to, or less than the second number, is you could divide the first number by the second number. If the ratio was equal to 1, those two numbers are identical. If the ratio is bigger than 1, the first number is bigger than the second. If the ratio is less than 1, the first number is less than the second. Or if you want, you could take a difference. You could subtract the second number from the first. If the difference is 0, the two numbers are the same. If the difference is positive, the first number is bigger than the second. If the difference is the second is less than 0, the second number is bigger than the first. What that means is all these measures of association, these measures of effect that we epidemiologists use, are used by measuring the outcomes in two groups of people, the exposed and the non-exposed, the spam users and the non-spam users, and taking ratios or differences